Welcome to today's Explainer. So today, we're diving into the invisible rules that completely run your life on the internet. Seriously, every single second, billions of data packets are just flying across the globe, handling everything from your bank transfers to live streaming. But have you ever stopped to wonder how all that data actually gets where it needs to go without turning into total chaos? Well, there is a massive, completely unseen operation happening right beneath the surface of your screen. Today, we're setting up a heavyweight matchup between the two core protocols that make all of this possible. If you want to understand how modern networking actually works, you have to know this stuff. We're talking about the Great Protocol Showdown, TCP versus UDP.
Okay, quick roadmap for what we're covering. We'll start with the transport layer arena, then meet our first contender, TCP, followed by our second contender, UDP. And finally, we'll put them head-to-head in the ultimate protocol showdown.
All right, part 1, the transport layer arena. Let's figure out where these protocols actually live.
We have to place these protocols within the grand scheme of things, specifically the 7-layer OSI model. They live right in the middle, in layer 4, the transport layer. You can think of this layer as the ultimate bridge. It sits between your application layers up top and the network layers down below. Its entire job is to take raw data and prep it for a highly unpredictable journey across physical networks. And to pull this off, it offers two very different types of services. Connection-oriented services, which meticulously track every single detail, and connection-less services which, well, they basically just throw the data out there and hope for the best.
A huge part of this is the process of segmentation and sequencing. Look, you absolutely cannot just shove a massive, uncompressed 4K image through a network cable all at once. It's literally like trying to carry a stack of 1,000 heavy encyclopedias in one trip. You're going to drop them. So instead, the transport layer slices that massive data up into manageable segments. Then, it slaps a sequence number on each piece. 1, 2, 3, 4, and so on. This way, even if piece number 2 takes a completely different path across the internet than piece number 3, they can still be perfectly reassembled into that exact same stack of books when they arrive.
Moving right along to part 2, TCP, the reliable connection.
Let's meet contender number 1, TCP, or Transmission Control Protocol. This is our connection-oriented service. If we're using analogies, TCP is basically a hyper-organized, super meticulous accountant. It gives you a rock-solid guarantee that your data is going to arrive error-free, perfectly in order, with zero loss and zero duplicates. It pulls this off by constantly sending acknowledgments back and forth and running all these complex math checks on every single segment. Basically, if you send a critical database file via TCP, you know for an absolute fact it's arriving byte for byte identical to how it left.
The thing to remember here is that TCP never ever just sends data blindly. It's got rules. First up is connection establishment, also known as the three-way handshake. A SYN goes out, a SYN ACK comes back, and a final ACK seals the deal. Both computers are formally agreeing to talk before a single drop of real data is exchanged. Then it rigorously sequences those data units so nothing gets jumbled. And finally, it runs a super strict error control mechanism. It's always watching those acknowledgments, actively hunting for any corrupted or missing packets.
Because of all these strict rules, the guarantees TCP provides are just ironclad. Error-free delivery, perfect sequencing, no data loss, and no duplication. If a flaky router drops a piece of your data somewhere in transit, TCP doesn't panic at all. It just pauses, looks at the sequence numbers, figures out exactly what went missing, and calmly asks the sender for that specific piece again. But, and this is a big but, this absolute reliability comes with a heavy cost. All those handshakes, error checks, and acknowledgments, they create a ton of overhead, and that inevitably means latency.
So, that begs a pretty obvious question, right? If TCP guarantees absolute perfection, why would anyone ever use anything else? Well, because out in the wild of modern networking, waiting around for perfection can completely ruin the experience.
Which brings us perfectly to part 3, UDP, the speedy sprinter.
Enter contender number 2, UDP, or User Datagram Protocol. This protocol completely throws the TCP rulebook out the window. UDP is connectionless. It operates without any of those strict error controls or sequencing guarantees we just talked about. No tracking numbers, no handshakes, no waiting around. Because of this, its header size is tiny compared to TCP. If TCP is our meticulous accountant, UDP is a reckless, lightning-fast courier. It doesn't introduce itself. It doesn't care if the receiving server is even ready. It just blasts messages out of the gate as fast as the physical hardware can possibly handle them.
And as the source material points out, that pure speed is exactly why everyone wants to use UDP when they can. Forget the guarantees. Sometimes you just need raw speed.
Think about multiplayer gaming, live voice over IP calls, or DNS lookups. In those real-time, split-second scenarios, you honestly don't care if a single tiny packet gets lost in the void. A dropped frame of video or a tiny audio glitch is way better than the entire stream freezing and buffering just so the system can go back and fetch one useless millisecond of old data.
All right, part 4, the ultimate protocol showdown. Time to put them head to head.
This is the core trade-off of the entire internet. With TCP, you get unwavering, bulletproof reliability. It's sequenced, error-controlled, and guarantees zero loss. It is the absolute champion when you're downloading a file, loading a complex web page, or sending an email, because missing even one byte would corrupt the whole thing. But then you have UDP. It's connectionless, it completely abandons error control, and it doesn't care about sequence. It willingly sacrifices all that heavy safety and overhead just to minimize latency and give you unmatched, blistering speed. So ultimately, the transport layer gives us these two completely different tools for entirely different jobs. Network engineers literally make this choice every single day when they build apps. It's a constant balancing act, weighing the heavy overhead of guaranteed perfection against the lightweight, raw potential of blistering speed. It's the literal foundation of how our data moves around the globe.
So, think about the apps you rely on every day. Next time you're on a live video call and the feed drops a tiny visual frame or glitches just for a fraction of a second, but the conversation keeps flowing without freezing to buffer, well, now you know exactly which connectionless protocol is working its magic behind the scenes, don't you? These invisible choices between perfection and speed really do dictate our entire digital experience. Thanks so much for hanging out with me for this explainer. Keep asking questions, and I'll catch you in the next one.